Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about Stoke Space update as of like January 23rd, basically progress so far made. So Stock Space, I have already covered them, but that time it was like they were very under the radar kind of thing. Now they have come up a bit more. So Stock Space, Andy Lopez and Tom Fiddleman, basically these two gentlemen has started this idea. And there are of course other more veteran players also involved in the game. Now, what is the unique selling point of both of them? Well, both of them worked in the early stages of SpaceX and Blue Origin, meaning nowadays every Tom, Dick and Harry talks about SpaceX, but yes, there was a time where they were the underdog, they were like unknown, they were working in that time frame. So they have a very different perspective of things, how things were, how things became the way it is. So that's some serious knowledge wisdom. So, and they have some serious investor money. So meaning the more than enough people are putting serious money in their pants where they're like, I can actually afford to build a rocket and actually launch it. So, and they can even able to afford one or two mishaps. So that gives them a confidence that they're not going to go poof very quickly. So some serious investor interest is there. On top of that, in terms of customer, are there any people who are lined up to buy their services? Yes, NASA and Space Force. Be fine for NASA is a bit more of commercial and scientific nature. Space Force is more of boom boom nature. Meaning Space Force is designed in such a way where it's like if China attacks Taiwan and starts to jam all the satellites used by American forces, they need to launch a new satellite after they have detected how they are blocking it instantaneously. Right now they have shrunk the time down to 24 hours, meaning DARPA gives them block of satellite, magic satellite, and that satellite could be put in orbit in 24 hours. So they are trying to shrink that. So Space Force, that's why they want so many options where they're like, go, go. They need that. So NASA's requirement is different and Space Force requirement is different. And if both of them are interested, that means you are literally in a position where if you can build it, what you are claiming, they will come. You do not have to worry about it. So that's there. And not only they are focusing on low Earth orbit, they are also focusing on deep space, meaning they can, their early plans itself has enough room, enough wiggle room so they can touch moon. So they are seriously focused. Let's just put it that way. Now, I always talk about this philosophy layer, which may sound odd. It's like, why you're talking about philosophy when you're talking about rockets? Here's the deal. What is the difference between ESA, ISRO, and SpaceX? Philosophy. One has more money, one has less money, one has more people, one has less people, but it's like, or more of them have almost the same amount of people. Then why the heck SpaceX is so far ahead of the whole planet? Basically, it's because of the philosophy. It's not that German engineers literally have a different science book than you. Like you can read that same engineering book, it's the same law, same everything. Then how the heck German engineers can build something so interesting? Well, the idea is always the same. It's about philosophy. It's never about the mathematics. That's fixed. Everywhere is a fixed thing. It's philosophy. So their philosophy, basically their CEOs or the foundation philosophy is very unique. The idea was, they noticed, practically speaking, in 2020, there was only one company that was doing reusable and every other company was on their last leg. Meaning they knew back then that ULA is in like, fighting for crumbs. And again, they are. The only reason they are there because USA have learned it the hard way that thou shall always have multiple players in the game. So ULA will have contracts, but again, even US government is like, we paid your basically Tony Bruno, before him there was another CEO, they were paying around $1 billion of subsidy annually. So fundamentally SpaceX and nothing else. That's not an acceptable scenario. So they are very clear. It's like only one company is doing it and it's not something that you can tack on. Like how Rocket Lab is trying to tack it on. It's working, but again, it's not very efficient, so to say. And again, even they know it. That's why they are focusing so much on neutron rocket. It's like rocket is one of those things. It's like you design it to do one thing, it will do that one thing. You try to tack on any little thing, it would be pain in the ass. So they have learned that lesson. Not only they have worked in the rocketry, they noticed that the market has this gap, whereas there's only one company that is doing true reusability. That's why Starship from day one is designed for 100% reusability. And they're like, hey, we need something else that is 100% reusable from day one. It cannot be like you tack it on. So 100% reusability is their core focus. And from day one, they knew this very early on. It's like rocket does not like to be like, what if we added this? What if we did this? It's like, no, it does not work that way. You have to be very clear from day one. And they started from first principle. This is another critical aspect. Why does rocket manufacturers choose lithium aluminum alloy? Well, it's one of the best alloy that we have for rocketry. Yeah, it's true, but why? Because it's Not expensive, it's idiotically expensive. It's like, do not ask, like give blank check kind of expensive. Like why Vulcan rocket is so expensive, the engine is not that expensive, engine is coming from private company, it's not that expensive. It's like you look at the sheet of aluminum they buy and then just take that aluminum and go and like 90% of mass is thrown away, and they're like, they recycle it. Here's deal, recycling is not 100% efficient, and again recycling requires energy. You just wasted that energy. So fundamentally they're like, hey, what if we just yeeted that and use stainless steel? And again, link video down below where they're talking about in detail why it's done. And the answer is very clear. Yes, you will get a bit more payload if you use lithium aluminum alloy or carbon fiber, but your cost will go exponentially higher, not a little bit higher, exponentially higher. Now, would that exponentially higher payload justify the cost? The answer was no. And that's why Starship does not have carbon fiber and whole. Again, Elon Musk did try that. If you remember the old photos, like 12-meter diameter carbon tank tubes and all that. Reality is the same. It's like, if you can't afford to build it, it's pointless. So that's why stainless steel. I'm like, wow, somebody went back to the drawing board, basically started with blank fresh page. So first principle operation is very rare, especially in government agency. Oh my God, like this personally hurts my soul as an Indian, is that I'm watching ISRO literally buying an ancient technology, as in from Soviet Union era, or maybe even older than that. It's like from Ukraine, the engine that is SCE 200 for us, that's the name in India, semi-cryogenic 200 engine. It's a kerosene and liquid oxygen engine. It's ancient. By modern design, it's already ancient. But here's the deal, they are still working on it, they are still paying money for it, their engineers are working on it. It's not easy. And this CEO had the line that I was like, damn, he can see, he has eyes. Any engine is hard. And I'm like, thank you. Rocket engines are fundamentally hard. So if you are actually pouring into the effort, like I'm gonna go through all the bells and whistles that I need to go through, all the hassles that I need to cross in order to build the damn thing, why not build a thing that has margin? I'm like, whoa. Like there's a reason to build modern engines rather than, like, building 1980s technology. Whoa. It's like, and again, it's very clear. It's like, if we build this full flow stage combustion engine, which is difficult, it's not going to be like 10 times more difficult. And they know for a fact that if they try to push it, then it's difficult. But if they try to keep it minimal, like, again, it will be minimal engine. But then, like, what's the point? Again, they will build a complete system and then they're going to upgrade it. Mark 2, Mark 3, Mark 4, Mark 5. Be mindful, Falcon 9 also did the same thing. Falcon 1, Block 1, Falcon 9, Block 1. Now they are at Block 5. Same thing happens. So this logic realization that there is no actual benefit of building a, it's easy engine. It's like, we are not in that era anymore. It's not V2's 1990s era. Like in modern world, you need to come up with modern solutions. So this line alone was like, damn, this dude knows his things. It kind of makes sense. He was there, like, I was there before it was cool. So there is some wisdom there. And that's why their engine looks so weird like this. Whereas, like, they have only one turbo pump, but it has so many nozzles. Why? Well, they wanted to force two things together. They wanted to make a baby out of two things. One heat shield, one rocket nozzle. Now, here's the deal. They do not like to make love to each other. So they put this design. This design is basically, you have one turbo power head, as they call it, one power head, and is putting fuel all around these puppies. All those puppies are controllable individually, meaning that's how they can do differential thrust vectoring, meaning they do not no longer need gimbals, and without gimbals they can still maintain all the axis of pitch, roll, yaw, and all that jazz. So the first principle operation, like, it does not even make sense. Like, how the heck, why you are doing, like, for example, going with stainless steel heat shield? Why? Well, that puppy can withstand a lot of temperature without, getting into fatigue zone, basically, where it's like, loses structural integrity. Because while aluminum will melt at a very high temperature, it will not last at very high temperature, meaning structure wise, it becomes very soft very quickly. So using stainless steel, okay, awesome, good. How are you going to cool it? Well, you put liquid hydrogen there, and that was the reason why they're using liquid hydrogen on upper stage. It's like, hydrogen gives you the best mileage out there, flat out, like everybody knows this. Methane is the second best, RP1 is the worst. That's why Falcon 9 is really not that good for deep space mission. But if you can use methane, why not use methane? Well, methane in liquid stage is not that good of a coolant, and they're like, hey, we need to reuse this puppy. So what is the best coolant? Hydrogen. Is there a benefit of that? Well, you get the best coolant and you get the advantage of high specific impulse. Now they are like, so we can kill two birds with one stone. They're like, okay. So you see, first principle, everything is from fresh. Nothing is like, what if we take 1980s technology and then we just blah, 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 blah into it? It's like, no, what if we start from fresh? Like, we need to solve this problem. Let's go to the first principle. Like you talk with this gentleman, it's like everything is thought through. It's like, why do we have this drop of fairing? Why do we have this type of structure? Everything is thought through, and from baseline. It's like, yeah, lithium aluminum alloy is awesome. It will give us more capacity. It's gonna bankrupt us. So philosophy is very clear, very awesome. So what about construction? That's just like talk. Well, like, okay, you have an idea. What can you build? Well, holy damn, they have learned from the best, and it shows. Flat out, it shows. They are like full hardware testing ASAP, from paper to actual rocket firing. That happened under 4 years. That's fast. So in terms of rocket parts, they are building each parts individually and testing them, and then attaching them, then testing them, then with like basically they are piling of rocket fire engine time way too quickly. They realized very early on, it's like you can build all the CAD models that you want. If you want to get it done quickly, you have to build it in real life. And they were very clear about it. Like, we do small tests and it's like, oh, we found out 30 problems with it. That's awesome. Now they are fixing that part. So, and they did something only an engineer could do. It's like, they're like, hey, we need to build the booster tank and we need to test it, the plumbing and all that jazz. Okay. So we have to build it. Okay. We have to build it this diameter. Okay. We have to build it this length. Not necessarily. Because once you have the diameter, you get almost all the feel of the real thing. But if you make it longer, it becomes harder. Basically, trucks have to extend that and all that. It becomes expensive. They're like, is it really necessary at this stage? The answer was no. So they're like, okay, take one axis and just shrink that. Basically, they removed, if I'm not mistaken, they did not added 2 rings. They needed more rings. They did not add 2 rings, and they're like, okay, let's just cap it up and then we're gonna run all the tests we need to run. That's like, that saves money, and more important than that, it gives them time, as in they can reach, build, test much quicker than anybody else if they would have directly tried to build a full scale one. And again, they are still figuring things out because the diameter is full. They are still gonna figure out the clamping mechanism and all that. I'm like, damn, that's like some engineering level stuff with money management, where it's like, I need this much data out of it. It does not need to be this expensive. Let's shrink it in one axis. Go. It's like, dang. That's a very clever. Again, I blame the 1 hour live talk that he did, and it's like, dude, he is really thinking through. It's not just like, okay, I have the money, let's just go with it. No. It's like, money cannot buy time. Money can only buy speed. So, and basically their factory and testing site, they're 3 hours far apart. I'm like, that was also like somebody sat down and thought about these things. The area they've chosen for their factory, they have a lot of talent there. The area they have chosen for testing, it has very easy access, 3 hours of road drive, meaning they are sending stuff back in and forth every day, according to them, of course. But like, they're building it in a factory and then bringing this here, not that expensive. So everything that we have seen so far shows speed, agility. Now, what about testing? That's okay. We had philosophy, we had the construction. Did they actually do anything? Answer is, they are not shy about it. Let that be very clear. They are testing everything multiple times. Look into their Twitter, look into their Instagram. They're not shy about it. They're like, oh yeah, we are testing it. And they're doing it so quickly. And they're building their knowledge base very rapidly, because they've realized very quickly that this hop, like, was that benefit his deal. They had this much knowledge before the hop, this much knowledge after the hop, and that's what they learned from SpaceX, where it's like, you can do all the hululu in the world, or you can just build the damn thing. Building the damn thing clears far more information. Even if it's a failure case, you'll be like, damn, we learned so much. So fundamentally, hot static fire test, rocket engine nozzle test, all of them, they are going all in, no holes barred. They're going bonkers with it. And they call their own prototype engine as breadboard engine. So if you are familiar with electronics, you must be familiar with things like this, where you just like, attach modules with no longer soldering and all that. It's like, is that a way of building a rocket engine? Hell no, not a production engine. But if you want to test the concept, if you want to test, does this turbo pump design, does this impeller design work the way that we expect it, does the valve logic works the way we do, you can do that in a breadboard engine, and that will allow you to fine tune things that will take other companies decades. Look into how long it took NASA to figure out how to freaking start the engine of a space shuttle main engines, RS-25. Like, it was expensive and tedious. So they're like, hey, breadboards. Again, I do understand that's not a physical breadboard, but you get the point. It's like, let's sort things out, like let's not waste time. It's like, it's working or not. It's like, put this part, test this part, attach it with something else. Does it break? Okay, fix that, then move forward. Everything is very clear. And let this be realistic, real data. It's like, in the 4 years, the movement speed from paper to outcome of like an actual hop on a rocket engine that most people cannot even comprehend. Is like, wait a minute, here there is one power head and so many nozzles with thrust vectoring. They did it, take it and go in 4 years. That's not fast. That's like flash speed fast. That's like, damn. So what can we expect in the future? Well, they do have certain unique luxury. First of them is like they have first-hand experience of early rocket era, meaning they know how SpaceX became SpaceX. They know how Blue Origin became Blue Origin. So that sort of knowledge is not something that you can just look from outside. Somebody has to be from inside. They are there. And I do not mean in like technology, intellectual property theft. It's not necessary, especially when you are starting from blank page. You do not even have to worry about it, unless there is like they randomly found out some weird patent law. But most of the time, they won't have to worry about it, and they really know what they are doing. The only way you can achieve this sort of efficiency is that people on the top actually know what they are doing, and I mean to like deep level. Okay, this is what we are doing. So. And they have actual real usefulness, meaning unique selling point, where they're like, okay, you do this, no other company can do that, so that makes sense. Is Starship is going to be awesome? Absolutely, but it has still that issue. It's huge. What does that mean? That means it requires bonkers amount of propellants. Those propellant, remove cost of everything, assume rocket is free. The propellant cost of this puppy versus Starship, yeah. So there is some law of physics. While Elon Musk can say, oh, the completely reusable rocket would be 3 or 4 million, it would be lucky, like ludicrously lucky, if you can bring the price to, let's say, 300 million. Like early stages, maybe like 10, 20 years down the line. But early stage, what the hell are you going to do at that point in time? They notice there is a gap in the market. So they have actually, oh, there is a gap that's going to open up, which again Neutron is also trying to fill. So you can see that there is like a lot of competition there, and Neutron has the side effect of being second stage, being disposable. This has full recovery. So they notice something, there is a gap, there is a chink in the armor, they're like, bam, market is just right. And this is another aspect they talked about, is like if they had tried to make their own company in 2010, it would not have worked. The talent pool was just not there. But after the success of basically all other companies and the recent innovation upgrade, from so much attention, so much money being poured into it. So basically back in the days, you will have 100 graduates that is going to deal with rocket engines. Now you have thousands. So exponential amount of talent pool has been created. Now you can draw the best of the best. So they are on the right path. They have already started and they are moving at super high speed. All those things are awesome. Like think about this way, they are designing from day one that it should be reusable. Why they are designing it to be refuelable in space? Well, if they do that, that's the only way they can bypass that LEO limitation. Most rocket can easily go to LEO. The moment you're like, hey, take this payload from LEO to GEO, rockets are like, yeah, can't really do that. But you make it refuelable, GEO, man, that's easy, man. I can go to the moon, and given the fact that it has a heat shield, it can do landings. Same technology. They thought this through. It's like, hey, if we really go with this style, we are no longer limited to low Earth orbit. We are no longer limited to even geostationary orbit. We can like literally go to moon. And maybe even Mars, if they can like have a folding solar panels or something like that, they could even be able to pull through Mars. Like, of course, let that be very clear, very little payload, but they can. So it's a very thought through, like it shows, like every aspect of the system shows that somebody started from fresh. That's like how Starship looks so futuristic compared to everything else. That's the main reason. It's like it's from a fresh start. Falcon 9 was not from a fresh start. So this is another rocket that is from a fresh start. Neutron, let's say how it comes up. And I have to say one thing, CEO knows how to advertise effectively, because you have to understand, when you are a young company, you do not really have that deep of a pocket where it's gonna make everybody rich. And be mindful, ESA pays bonkers amount of money for its people, like bonkers amount of money. Like if you think NASA space is good, look into ESA space, you will be like, damn. So how the heck you as a young startup company is gonna attract people? Well, young people need two things, either money or fame. You don't have money, so you can have fame. How can you have fame? Well, you show glory. It's like, we are doing glorious thing. You do not say, oh, we are building a cheap ass rocket that is cheap ass rocket. It's like, no, we are building the unthinkable. You have to understand, there are two types of people. One, people who are just like, I need money for food. That's like bare minimum people. That's majority of humanity. And then you have competent people. Those are like, 1 in 1,000 kind of people. But those people, they can move mountains. Only issue is, you cannot ask them to work on bitch ass project. The project has to shine. There has to be like, whoa. It has to be almost impossible. If that is there, then they're like, I got you, fam. So marketing matters for that. Like if you want to attract those sort of people, competent, driven, passionate people, especially from the age group of 25 to 30, you need to be out there. You need to be more attractive. How do you do that? Precision marketing, meaning let's say a CEO's, his time has X amount of value. He's like, hey, let's bring Tim Dot. Again, let's say that's a 1 day of shoot and all that. So, okay, he loses X amount of value, financially speaking, but this video will be seen by a lot of people. That will not only increase your soft value, but it will also reach to the people who are interested in rockets, students, and many of them like, you know what, it looks cool, I want to work there. Like he's giving 1.5 hour detailed live streams, and I'm like, damn. And the detail is like, he flat out clears like, this detail I can't share, this is like, you know, of course rocket laws and all that, but everything else is like, why I'm selecting this design, why this is that, how we are doing it, how, what are our pain points, everything. I'm like, damn. It's like, the dude knows. And again, when he talks, it's a different kind of talk compared to Elon Musk. Elon Musk is a guy from a surface level. This guy is the rocket engineer. He's like, I am the guy who builds the rocket. So there is a very different level of depth. So I would say the CEO is like, he knows marketing. So next 4 years would be very interesting to see. And I do expect them, if they can maintain their current speed, next 4 years from now, we will be talking about their landings, or maybe even landing on moon. That's how good they are at current speed. So future is very interesting about this company, and they do have some deep pocket backing them up. So let's see what happens. So this was my presentation on Stoke Space. Hopefully you have liked it, learned from it. In that case, please hit the like button, share it amongst friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.